What's up, guys? We are going through lesson 11 today, which is on properties of tangents. So remember your types of lines. A tangent line is a line that touches the circle in only one spot, okay? Chords, remember, go from one point to the other. They don't extend past the circle. A secant line crosses through the circle and goes outside the circle, okay? Cuts through twice. Tangent hits once, secant twice. Diameter goes through the center, and remember the radius is half of the diameter. So the two theorems, really three, we'll get one later today, we're going to use today are, number one, we call it the hat rule. The hat rule is not a math term, it's something I like to use, but it looks like if you put a hat on a circle, see the hat right here, okay? These two lines, these two tangent lines that intersect at the same point are equal, okay? So two tangent lines that intersect at the same point outside the circle are equal to each other. So if you put a hat on the circle, remember that the two sides there are the same. Okay, the second one is that any tangent, okay, that intersects a radius is perpendicular at what's called the point of tangency. That's where the tangent line hits the circle. All right. And the third one, remember, just a refresher, the opposite angles formed in a quadrilateral add to 180 degrees, and we'll get there a little bit later in the lesson. So those are the three we need for today. So going back over to our first question, I'm just going to make this so it shows up right. All right. We're going to do a two-column proof. We're not actually going to do a two-column proof. We're going to walk through this for you guys. So in the proof, what they want you to do is they actually want you to draw in these two radii. Okay, any 2 points you can draw a line and draw in this line AC, and we form these two triangles. So what we really want to do is show that these two triangles are equal. Okay, so the first one would be that these two lines are equal, okay, and that is lines AD and AE, because all radii of the same circle are congruent. All right, remember we just talked about the tangent is perpendicular to the radius. Okay, and the last one would be is that we have the reflexive property. So these two triangles are going to be equal because of the hypotenuse leg theorem. So that's right triangles because it has a right angle, and then HL, and then CPCTC. So that's pretty much the proof of it. We're just going to use it. Okay. So in circle A, the radius is 9, so that's the length of AB, and we want to find the length of BC, or we know the length of BC is 12. We want to find AC if we draw this out. So just remember the tangent line here, okay, is perpendicular to the radius. So this line of 12 is perpendicular to the 9. And then we can just use some good old Pythagorean theorem here. So A squared plus B squared is equal to C squared. So 9 squared plus 12 squared. And this is 144 plus 81, which is 225. And then when we take the square root of that, we should get good old 15. And by the way, this is a 3, 4, 5 right triangle, but everything is just multiplied by 3. So keep that in mind. All right. And then we want to find the area of triangle ACD. So just remember that these two lines, BC and CD, because they came from the same point, right? They're equal. So this side is also 12. All right. We know this is 15 now, and we know that these two radii are equal, so this is 9. So the area of the triangle is 1/2 base times height. And remember, in a right triangle, it's actually 1/2 the leg times leg. All right, so it's 1/2 9 times 12. And really, you can do half of the even numbers, so really 6 times 9, and that should be 54. And this is like units squared. And then find the perimeter of quadrilateral ABCD. That's just find all the side lengths going all the way around. So ABCD would be this guy. Okay. Remember, perimeter is just add all sides. Add all the sides. And so this is just going to be 9 plus 9 plus 12 plus 8, 15, oh, another 12. That's 18 plus 12 is 30, so how about 42 units? Whatever they are, millimeters. So this happens to be millimeters squared, and this is just straight up millimeters for the area and perimeter. Okay, new question number 3. All right, EF is 12, so it looks like that's this line right here. That's 12. AE, which is this line right here, is 13. And it says the length of AE to AC is 1 to 3. Okay, so that would mean that if this is X, right? Remember we talked about if we see a ratio, X is the common factor. So if this is X, that means that AC is 3X. So we would know that AC is 3 times 13, which is 39. 3 times as big. Okay? We want to find the radius of the circle. So the radius we could draw in would form a triangle here, right? Let's do it in red just so you can see the red triangle. Here's a red triangle with the radius. And remember, this line is tangent, right? EF is drawn tangent to the circle. So this is going to form a right triangle here. Okay, so we are going to want to and really what this question is missing, what it should say, is that, no, we're going to scratch that. We don't know that. This is the problem we have. I don't know that EF, because it doesn't continue on at one point, I really know that it only hits at one time. Really, they should be saying that lines EF and ED are tangent. So we can kind of tell here that this line ECD, though, is tangent. So this being 13, if this line is 12, so is this. This is the problem here. This needs to be a tangent line. It needs to be stated. It's not. So we're going to put that in for ourselves. So we'll say EF and EC, that's an and symbol, terribleness, are tangent lines, okay, to circle A. This is really what should be in this question, all right? Now, knowing that, it doesn't state it anywhere, now we can do this. So this radius here, okay, and now we can, this is going to form 90 degrees, which is essential to do this, and then we can use our c squared, and remember it's minus b squared formula, equals a squared because we're looking for the leg, and we can plug in. So 13 squared minus 12 squared is equal to a squared. So this is 169 minus 144, which is 25. And so square root time, and a is equal to 5. So now I know that any radii I draw is going to be 5. So likewise, if I draw this in, and this is 5, now I can go figure out the length of BC. And we know it's going to be a decimal because it says round to the nearest whole number. So same thing though. Here's our right triangle. So that's C. We'll call that B, and there's A again. So we can do C squared minus B squared is equal to A squared, and then 39 squared minus 5 squared is equal to A squared. And I would just do 39 squared minus 5 squared on my calculator here. So $39 squared is 1,521 for those of you who would like to know. But this comes out to be 1,496 is equal to A squared. And so when I take the square root, the nearest whole number here is going to be, well, the decimal is 38.7 technically. It's 6, 7, 8, whatever, but we're going to round it accordingly. So it is going to be, actually I should just ignore that. I did it wrong, didn't I? This is a 6 is the next number. So this is automatically going to push this up to 39 for the length there. Which seems weird, right? Because if we're rounding it to 39 and the one side is 39, then it should be an isosceles right triangle, and how can that be the same size? But remember, this is 39. This technically is less than 39. It's 38.6, but we're rounding it to 39, okay? And then we want to find the length of EC. So we know, once again, okay, that these two lines are tangent, okay, to the circle. Therefore, they come from the same point, they're equal. So this is also 39. And then we can just add those together. So that's 12 plus 39. And that's going to be our length. So that's 51 units here because there isn't a measurement. All right. So remember, the tangent line is perpendicular to the radius of a circle, the point of tangency. Okay, it's only tangent if and only if it's perpendicular to the radius. If it's not perpendicular to the radius, it can't be a tangent line. Some other vocab here: interior of a circle is any point that's on the inside of the circle. So the radius is less than 0.0, the center is less than r. Exterior, the radius would be bigger than r. I mean, it's just getting a little crazy here with the definition. So just interiors inside the actual points that are the same distance away from whatever the radius is. Tangent to the circle, remember, crosses through at only one point on the circle. The tangent segment or tangent ray is the set of points that do that. A secant line, remember, it's a line, so it goes on forever. Instead of a line segment, it intersects at exactly 2 points. The polygon, remember, it has to have the vertices on the circle. And inscribed means that the circle goes through the vertices of the polygon. Okay. Fun times here, right, guys? So problem set, if AB is 5, so that's here's 5, BC is 12, and this is 13, they want to know, is this a tangent line? So remember, in order for this to be a tangent line, this has to be a right angle. So to check for a right angle, we have to see, does the Pythagorean theorem work? So if I start with a squared plus b squared equals c squared, I'm going to plug in, is 5 squared, right, plus 12 squared, is that equal to c squared? So I'm going to do this first, okay? 5 squared plus 12 squared is 25, plus 144. This is 169. Off to the side, I'm going to do 13 squared. This is 169. So therefore, we can say yes, okay? BC is tangent to circle A, since angle B, we can't say angle B, angle ABC is a right angle, right? We could actually say, since triangle ABC is a right triangle, but more importantly, it's a right angle, okay? Since 3 squared plus 4 squared equals 5 squared. Or sorry, not that. 3 squared plus 12 squared. I did 3 squared. There's no 3 here, guys. It's late over here. All right. Equals, and then 13 squared. Oh, you're killing me, Smalls. Name the movie. If you said Sandlot, you're correct. Okay? So the Pythagorean theorem works. It's a right angle. We're good to go. All right. So same type of thing here, except we are going to get some fun times for this question. All right. So find the radius of the circle, find AC. So these are in 2 steps. We have to do the first one. To do the second one, we have to figure out R. Now, remember, this is tangent, so it is going to form a right angle. Okay. This side is the sum of R plus 9. So in order to figure this out, we have to use Pythagorean theorem, but one of the sides is R plus 9. So it's going to be a, get this, guys, it's going to be a quadratic, sort of. Okay. So R plus 9 squared is the hypotenuse, that's c squared, is equal to r squared plus 15 squared. Now remember, r plus 9 squared is not equal to r squared plus 81. That is the big mistake that people make here. Okay, what this is equal to is this multiplied twice. It's squared for the first one, 2 times r and 9, and then 9 squared. So it's distribute, right? You Yostros fans here, r squared plus 9r plus another 9r plus r squared again. No, 9 squared. So plus 81. All right, getting towards the border there. So r squared, 2 times 9 times r, right? So plus 18r plus 81. This is what this equals. Okay, so we'll bring it back in our question. R squared plus 18r plus 81. And then r squared plus 225. Now, normally when we solve a quadratic, we want to get everything on the same side. In that process, the r squares are going to cancel out. So it's going to start as a quadratic, but it's actually just a linear equation here. And I get 18r plus 81 equal to 225, and I just keep solving. So now I'm going to move the 81 over and then divide out by 18. So 4 borrow is 144, and then divided by 18 should give us the answer. And 8. So the radius, okay, for part A, the radius is equal to 8. All right. And then part B, AC, right, is equal to 8 plus 9, which is just 17. Okay. Circular pond is fenced on 2 opposite sides. All right. CD and FE with wood, and 2 of the other sides with metal fencing. If all 4 sides are fenced tangent to the pond, is there more wood or more wood metal fencing used? So 2 opposite sides. So CD and EF are both wooden. Okay. Maybe there's houses on, 4 houses surrounding this thing. The other 2 sides are metal. They want to know which is bigger. It's an interesting question, actually. Because at first sight, you might say, well, the metal's bigger because this side's like super long, right? But you guys got to remember the hat rule. Okay, hat rule. 2 lines. These 2 lines are tangent from the same point outside the circle. Okay, these 2 lines have to be equal. All right. Same thing. These 2 lines have to be equal. They're also tangent from the same point outside the circle. These 2 lines have to be equal. These 2 lines have to be equal. Okay, so we have pairs of equal parts. So if you look, right, we can put numbers down. Let's call this 6 and that this is 6. If this is 7, this is 7. If this is 10, this is 10. And if this is 3, this is 3. So really, this metal side has a length of 9. This metal side has a length of 17, right? So that's, what, 26 together? And then this wooden side has a length of 13, and this wooden side has a length of 13, that's 26. So is there more wood or more metal fencing used? Neither, right? There is an equal amount of wood and metal fencing used, since the tangent lines from the same point outside the circle are equal. And I'll put hat rule. Not an official geometric term, guys, but it's our way to recognize this is going to be equal. This is the last question we're going to do. The next page has some questions, but they're a little funky, and I do not want to talk about them. I'll show them to you guys. Not going to do them, though. Okay? Actually, we can do one of them. If x is shown below, is find x if the line shown below is tangent. So if this line is tangent to the circle, that means that this line is going to create a 90-degree angle here. All right, we also have this triangle chilling here, which you might notice is a certain type of triangle. If you notice these lines are radii and they're equal, that this triangle becomes isosceles. So we need to first figure out the measure of this angle here, and then we can get x. So 180 minus 134 will leave us with 46 degrees. And then we just divide that by 2 to get 23. So both of these angles measure 23 degrees. So that means this angle where x is just 90 minus 23, which should be 67. So x is equal to 67 degrees. We'll talk about this one, and then we're not gonna, we'll talk about that one, but we're not gonna get into it too much. They get a little, we don't need to know the stuff they're gonna ask in the next view. So number 5, PC is tangent to the circle at point C, and CE is equal to DE. So we know that line CD is equal to line DE. All right, and then what we're going to do is we need to figure out the arc CD and then angle CFE. All right, now 2 things. If these 2 arcs are equal, these 2 chords are equal. Remember, congruent chords make congruent arcs. These 2 arcs are actually going to be equal to each other. So going back here, those 2 are equal to 1 slash. These 2 arcs are actually equal as well. So we can call this arc here also x. Okay, not drawn to scale. That's key here. So remember we talked about, we haven't used it yet, but we talked about the opposite angles of a quadrilateral add to 180 degrees. And we're going to use, remember that an inscribed angle, right, the measure of the angle, okay, is half the measure of the arc. So if I know the angle, I double that measure to get the measure of the arc. All right, so if I see that this angle is 76 degrees, that means that y is just 180 minus 76, all right, which should be 104 degrees. Now, keep in mind that this angle is inscribed, okay, to this entire arc. So if this is 104, this arc has to be 208 degrees, and it's cut in half. So x is just half of that. So this is 104 degrees over here and 104 degrees over here. Remember, not drawn to scale. That's it. Now it looks like there's a z over here, but we have no way to get that. We would have to know the measure of this arc here to make that happen, which we don't. So that's it. We're stopping. Okay. Number 6, construct 2 tangent lines to circle A through point B. What I would normally do is, and this is the easy way to do it, take a ruler and draw it so it's only going to hit one time. So take a ruler, right, point B, draw it so it hits one time, we're good to go. That's it. That's what they want you to do in the module. So nothing too crazy. If we were doing this, okay, and we wanted to create a tangent line, I would want to draw a radius first and then draw a line perpendicular to that through B. But remember, the radius can't just go anywhere. It has to make sure when you hit, it has to form 90 degrees here. So I have to have like the tangent line first to make the radius. So that's why I don't like this question. And this question I am not a fan of at all. What they essentially want you to do is draw, okay, a rectangle here, and then, or a parallelogram at least, and actually it would be a rectangle because it's got a 90-degree angle here, and draw this so you can figure out what the measure is. So this you can see right here is 5, 4, and 3. So we know this entire side here is 5 plus 4 plus 3, which is 12. And this is a radius, so this is 5. And then I could just figure out, right, that this is 3 because this is this radius, okay? So this is 2. And then I know this is 12. And I can use Pythagorean theorem. Like, they're never going to ask this on the exam, okay? I mean, this question is out of the box to get that rectangle in there. So, okay. And then these questions, the same thing. This actually involves similar triangles. This is kind of neat. So if I draw this line in here, which is the radius in both of these, we know we're going to create 90-degree angles, and they share vertical angles. So we have angle, similarity, and now I can do a proportion. So if the circle of radius A is 9, that makes this 9, and the circle here is 5, those two sides are corresponding. Okay, it says the circles are 2 units apart. Okay, so we would know, for instance, that this line is 9 to get to here. All right. Trying to check if it sees that this is right in the middle. And this is 5 to get to here. And we're going to say, like, this is, if this is an extra 1 on both sides, we'd have 6 and 10, and we can figure out what those are going to be from here. This is where it gets a little weird. So that's why I kind of want to stay away from these questions, but we do create some similar triangles, and we're going to solve from there. So it gets a little funky when you're doing this. So I'm not going to worry about number 8 or the last one. That's it, guys. Hope you had a great day. If you have any other questions, please let me know. We will be doing a live stream at 11 o'clock tomorrow, or, well, it's really today now. So have yourselves a great day, and we'll see you tomorrow, guys.